Okay, so this is just some like extra clarification and assistance on things like polar and non-polar covalent bonding. It's down to electronegativity difference, and the big thing I almost always ask is for you to identify, here are the two atoms that are bonding, here's their electronegativity, what kind of bond is this? So we know that if it's down here, very low electronegativity, that is nonpolar, polar, and then up here we get into our ionic bonds. So that, I think, is good with everybody. Okay. This thing. So the metaphor that I come back to again and again and again is the whole sharing a plate of cookies. Or sharing the covers on a bed if you've ever been tossed into bed with a bunch of siblings or cousins, or sleepovers when you were 10 or whatever, and there's always a blanket hog. The atom that is the most electronegative is the blanket hog, and the electron cloud is the blankets. So if we imagine fluorine and just about anything, trying to think of a covalent bond for fluorine. Hold on that. Ha 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 ha. Great. That was very helpful. Okay. Polar, non-polar, and my apologies. So, higher potential energy equals less stable. If you have a cliff and a big boulder on the top of the cliff, it's got lots of potential energy there, but it's really unstable. If it's sitting down here, it's very stable, but it doesn't have any potential energy. So the higher the potential energy, the less stable something is. When two atoms, and again, I'm just doing my this thing, when they are unstable when they're by themselves, but stable, stable when they're bonded, they will bond. Is that, that's really the whole idea that you need to get. Is if they're more stable when they're bonded together, they have lower potential energy, they'll do that. Other questions? Bond energy. Okay. Again, let me give you the highlights on really all I expect you to know. I'm using my generic ABs again. In general, single bonds are longer than double bond, or single, okay. Jeez Louise Moser. And how did I get a carbon in there? Because I love carbon. Because I like to count to 4. In general, longest to shortest. Single bonds tend to be longer. Double bonds are shorter. Triple bonds are even shorter. And it's the inverse relationship with energy. So high energy, low energy. So the longer the bond, the lower energy it is. The shorter the bond, the higher energy it is. And this is where you should remember the story of my friend, Mike Kaskowski. Yeah, I won't even claim him. He's my husband's friend. Who used MAP gas, which has a double bond, in a potato cannon that was engineered for propane, which is single bonds, and he nearly killed himself. Double bonds have more energy. More bang for your buck. Other questions? Okay. You got time to work, study. I don't know if I don't know how any of you study for chemistry. I don't know if you do study for chemistry. When I was in high school, I didn't study for anything like as a moral and philosophical position. I could smack me. What a jerk. And I tried introducing this with my general sophomores. They don't care. They philosophically do not study. So, but you guys might find it useful. Especially if you're very much a visual learner, or if you're very auditory, I think it helps for multiple learning styles. Now, if I were doing this, because now I actually know how to study, glossaries are fantastic, and I've had my biology kids making themselves video study guides. So like actually going through questions for themselves and recording it. So you're recording your own voice, you can play your own voice back, which helps if you're auditory. If you're kinesthetic, the act of drawing it and speaking it helps you. So it can help with multiple learning styles. And if you're really visual, finding and drawing the pictures is real helpful for you. So, and with you read-write learners, you know, the act of writing it probably helps. But sentences are more helpful for read-write learners than bullet points. I know that. So.
Okay.